All right, so now we're going to solve compound inequalities involving and then we'll graph our solution. So this one on the left, that's one where it's all connected. And you can see you've got your left section, your middle section where your x will be, and then your right section. Part B, we can see it is separated with the word and. And in an earlier video, we did see how you could write those both ways. So if it's all connected, we solve this by focusing on the middle section and saying we have to get that x alone. So what's the opposite of adding 9? What's the opposite of multiplying by 7? So the opposite of adding 9 is to subtract 9. So we're going to subtract 9 from the middle, and then we know to subtract 9 from the other side, right? Well, there are two other sides. So you have to subtract 9 from that section on the right, and you have to subtract 9 from that section on the left. 9 minus 9 cancels in the middle. Negative 12 minus 9 is negative 21. I'm going to carry down as less than or equal to. We have a 7x left in the middle, which is less than 7. 16 minus 9 is 7. All right, now we go back to the middle. We don't have the x alone yet. We have to get rid of that 7. It is being multiplied by 7, so our first step will be to divide by 7. Now, just like the last step, if we're going to divide by 7 in the middle, we have to divide by 7 on the right, and we have to divide by 7 on the left. So negative 21 divided by 7 is negative 3, is less than or equal to. Your 7's cancel, leaving you with x, and then is less than 7 divided by 7 is 1. So this is solved because you have x alone in the middle. So we're able to graph the solution. What we're saying is that negative 3 is less than or equal to all your x's, which are your solutions, which is less than 1. So basically the x's will be between negative 3 and 1. It will include the negative 3 because of the or equal to. It will not include the 1 because it's just less than. It doesn't have that or equal to. So let's put that on a graph. We need negative 3 on our number line, and we need the positive 1. So negative 3, negative 2, negative 1, that's where 0 is. That's where positive 1 is. We can see negative 3 is less than or equal to x, so we want a closed circle at negative 3. And if you think about which way should we shade, to the right or left, it's a less than or equal to symbol, but x is over here. So if you read it backwards, x is greater than or equal to negative 3. So we do want to shade the values that are bigger than negative 3. All right, we also know that x will be less than a positive 1. So we go to a positive 1, that is an open circle. X is less than the 1, so we need all the solutions less than. And you can see that we basically are shading everything between these two. That is our solution set. The negative 3 is included as a solution. The positive 1 is not included as a solution. All right, part B. Now we're just going to solve this. When it's separated out for you like this, with the and or with the or, you can just treat this like two different problems and solve one, solve the other, and let's see what it looks like on a graph. So this one on the left, we're going to start by distributing that negative 2. Negative 2 times x is negative 2x. Negative 2 times positive 1 is a negative 2, is less than 4. And then we're just going to solve. We will add 2 to both sides first. Negative 2x is less than 6. Divide both sides by negative 2. Now we are dividing by negative, so that's going to switch our inequality to be greater than negative 3. Carry down your and then we're going to solve this one. We'll start by subtracting 1 from both sides. 4x is less than or equal to negative 4. Divide both sides by 4. Now because what we're dividing by is positive, we do not flip the inequality. It doesn't matter that this top 4 is negative, but we're dividing by a positive 4, so our inequality does not change. So x will be less than or equal to negative 1. All right, so x is greater than -3 and x is less than or equal to -1. So let's see what that looks like on a number line. Let's see, we need a circle at -3. Here's -2. We need a circle at -1. I like to throw 0 in there. All right, x is greater than -3. So open circle at -3. For x to be greater than -3, we're going to shade to the right. And then x is less than or equal to -1, so we need a closed circle at -1 because of the or equal to. And then for x to be less than, it's going to shade all the numbers smaller, and you can see that we are shading everything in between. That's the overlap there of that solution. So your and inequalities will shade toward each other like that.